We can now edit DNA like a Word document, detect ripples in space-time from 1 billion years ago, design world-saving vaccines in less than a year. All of this happened in the 21st century. What you think is science fiction is now science fact. Today, we're counting down the top 10 most mind-blowing scientific discoveries reshaping our world since 2000. These aren't small steps. They're giant leaps that changed how we understand life, the universe, ourselves. We went from dreaming about these things to making them real in just over 2 decades. This is going to be the craziest countdown you've ever seen. We're talking about everything from the instruction manual for being human to discovering thousands of new worlds outside our solar system, to finding the particle that gives everything mass. It's insane. I've spent the last month digging through hundreds of papers and talking to experts to bring you these breakthroughs. So, get ready. We're about to explore the science building tomorrow, today. Everything here is backed by solid evidence. All facts are sourced. Check the description for primary papers and links. Kicking off our list at number 8 is one of the most ambitious projects humanity has ever undertaken, completing the Human Genome Project in 2003. Imagine trying to read a book with 3 billion letters, with no chapters, no punctuation, in a language you barely understand. That's what scientists did. For over a decade, thousands of researchers around the world worked tirelessly, piecing together the entire human DNA sequence. It was a monumental task, costing billions, but the payoff was massive. This wasn't just reading our genetic code, it was the ultimate instruction manual for a human. Before 2003, genetics was like a blurry aerial view of a city. We knew there were buildings and roads, but not the details. The Human Genome Project gave us the street-level map. Suddenly we could pinpoint genes responsible for diseases like cystic fibrosis, Huntington's disease. This opened a new frontier in medicine. We moved from treating symptoms to understanding root genetic causes, paving the way for personalized medicine. Coming in at number 7 is a discovery that changed our place in the universe. Before the 2000s, we knew of only a handful of planets outside our solar system, and finding them was incredibly difficult. We were basically alone. But then, in 2009, NASA launched the Kepler Space Telescope, and everything changed. Kepler's mission was simple but profound. Stare at a single patch of sky containing over 150,000 stars and watch for tiny periodic dips in their brightness. Those dips meant a planet might be passing in front of its star. It was like trying to spot a flea crawling across a searchlight from miles away. And what Kepler found was absolutely staggering. It didn't just find a few planets, it found thousands. The data that poured in from the Kepler mission, and later from its successor TESS, proved that planets aren't a rare exception. They are the rule. Almost every star you see in the night sky likely has at least one planet orbiting it. Our galaxy is teeming with worlds. We went from feeling lonely in the cosmos to realizing we live in a crowded neighborhood. The mission found planets of all sizes, massive gas giants larger than Jupiter, small rocky worlds similar in size to Earth. For the first time, we had concrete data showing that Earth-sized planets in the habitable zone, the region around a star where liquid water could exist, are common. Scientists now have a catalogue of promising targets to study with more powerful telescopes, like the James Webb Space Telescope, searching for signs of atmospheres and life. Kepler didn't find aliens, but it told us exactly where to look. At number 6, we're diving deep into the subatomic world with the discovery of the Higgs boson in 2012. For decades, there was a huge hole in our best theory of particle physics, the Standard Model. This theory perfectly described all the fundamental forces and particles that make up the universe, except for one thing. It couldn't explain why any of those particles have mass. The theory proposed a radical idea, an invisible, universe-spanning energy field called the Higgs field. Particles that interact with this field gain mass. Those that don't remain massless. To prove this, physicists had to find the particle associated with the field, the Higgs boson. So, they built the largest machine in human history, the Large Hadron Collider at CERN. This 27-kilometer ring of superconducting magnets smashes protons together at nearly the speed of light, recreating conditions just after the Big Bang. For years, thousands of scientists from around the world sifted through the debris of trillions of collisions, looking for a fleeting signature, the decay of a Higgs boson. Then, on July 4, 2012, the world of physics changed forever. Scientists at CERN announced they had found it. The discovery of the Higgs boson was a monumental triumph. It was the final missing piece of the Standard Model, confirming how the fundamental building blocks acquire mass. It was a Nobel Prize-winning discovery that validated 50 years of theoretical physics and gave us a deeper understanding of the fabric of reality. Finding the Higgs didn't just fill a gap, it solidified the foundation of modern physics. Cracking our number 5 spot is a technology so powerful it sounds like it's straight out of a sci-fi movie, CRISPR-Cas9. Discovered in 2012, CRISPR is essentially a pair of molecular scissors that can edit DNA with incredible precision. For decades, AI was promising but often fell short. Computers struggled with basic tasks that humans find effortless, like recognizing a cat in a picture. The field had hit a wall. Neural networks existed, inspired by the human brain, but they lacked the computing power and the data to tackle hard problems. It was an engine without fuel. Then everything changed at the ImageNet competition, a massive annual contest to identify objects in photos. A team from the University of Toronto, led by Alex Krzyzewski, submitted AlexNet. It didn't just beat the competition, it annihilated it. AlexNet's error rate was almost half that of the next best entry. The field was stunned. They had cracked the code by combining massive data sets, powerful new graphics processors, and deep, multi-layered neural network architectures. This wasn't just a competition win, it was the starting gun for the modern AI boom. Within years, deep learning powered everyday tech. Your phone can recognize your face, Alexa and Siri can understand your voice. YouTube recommends this video to you. It's the foundation for self-driving cars, medical image analysis that can spot cancer better than human radiologists, and large language models like ChatGPT that are changing the world right now. The 2012 AlexNet moment was the big bang for an AI universe we now live in. CRISPR changed the game completely. It's cheap, it's easy to use, and it's incredibly precise. It acts like a search and replace function for the genome. You can tell it what genetic sequence to find and it goes there, snips the DNA, and allows scientists to delete, repair, or replace the targeted gene. The implications were immediately obvious and absolutely massive. The first CRISPR-based therapies are already being approved for patients. But the impact of CRISPR goes way beyond medicine. In agriculture, scientists are using it to create crops that are more nutritious, resistant to drought and disease, and have higher yields. In biology, it has accelerated the pace of research exponentially, allowing scientists to understand the function of genes faster than ever before. Of course, with great power comes great responsibility. CRISPR has also sparked intense ethical debates about the possibility of designer babies and permanent changes to the human gene pool. It is, without a doubt, one of the most transformative and controversial technologies of our time. Chapter 6. For number 3, we have a discovery that literally shook the universe and opened a completely new way of observing the cosmos. On September 14, 2015, for the first time in history, humans directly detected gravitational waves. For 100 years, these ripples in the fabric of space-time were just a prediction of Albert Einstein's theory of general relativity. Einstein himself thought they would be too faint to ever be detected. He imagined them as tiny vibrations created by the most violent and massive events in the universe, like the collision of black holes or neutron stars. To find these impossibly small ripples, scientists built the Laser Interferometer Gravitational Wave Observatory, or LIGO. It consists of 2 identical L-shaped facilities, thousands of kilometers apart. Each one shoots lasers down 4-kilometer-long vacuum tubes. The idea is that if a gravitational wave passes through Earth, it will stretch and squeeze space-time itself, momentarily changing the distance the lasers travel by a distance thousands of times smaller than the nucleus of an atom. It is the most sensitive measuring device ever created. For years, it listened in silence for a whisper from the cosmos, and then it heard a chirp. The signal, lasting less than a second, was the unmistakable sound of two massive black holes, about 30 times the mass of our Sun, spiraling into each other and merging over 1 billion light-years away. In that final moment, they converted several suns' worth of mass into pure gravitational energy, sending a shockwave across the universe that LIGO detected. This discovery wasn't just a confirmation of Einstein's theory, it was the birth of gravitational wave astronomy. We went from only seeing the universe to hearing it too, allowing us to witness cosmic events that are completely invisible to any telescope. Yeah, it really changed everything. Chapter 7. Our runner-up at number 2, the science behind messenger RNA or mRNA, had been developing for decades, but it was largely theoretical and unproven for vaccines. Traditional vaccines work by introducing a weakened virus. Traditional vaccines work by introducing an inactivated virus to teach your immune system what to fight. This process is effective, but it can take years, sometimes even a decade, to develop and manufacture. The mRNA platform works completely differently. Instead of injecting a piece of the virus, an mRNA vaccine gives your cells the genetic instructions, the mRNA, to build a specific piece of the virus themselves, in this case, the spike protein of the COVID-19 virus. Your immune system then sees this harmless protein, recognizes it as foreign, and learns how to build a powerful defense against it. The beauty of this approach is its speed and flexibility. To create the vaccine, scientists only needed the genetic sequence of the virus. They didn't need to spend months learning how to grow the virus in a lab. When the COVID-19 pandemic hit, this technology was put to the ultimate test, and it passed with flying colors. In less than a year, a timeline that was previously unthinkable, scientists designed, tested, and manufactured billions of doses of highly effective vaccines. This rapid response proved the power of the mRNA platform, not just for COVID-19, but as a revolutionary tool against future pandemics. The technology is now being explored for vaccines against the flu, HIV, and even as a personalized treatment for cancer. The 2020 vaccine effort was a defining scientific achievement of the 21st century. Well, frankly, it reshaped how we respond to outbreaks. And the number one most important scientific discovery of the 21st century is our newfound ability to perform global-scale climate attribution. For decades, we've known the climate is changing, but connecting a specific extreme weather event directly to human-caused climate change was incredibly difficult. Like a particular hurricane, heat wave, or flood, it was like knowing smoking causes cancer, but not being able to prove that it caused one specific person's tumor. This ambiguity made it easy for people to dismiss the immediate and local dangers of a warming planet. But in the 21st century, that all changed. Exponentially more powerful supercomputers running high-resolution climate models. The development of a new field called attribution science, we can now connect the dots. Scientists can now run thousands of simulations of a world with human-caused greenhouse gas emissions and without human-caused greenhouse gas emissions. By comparing these two worlds, they can determine, with statistical confidence, how much more likely or intense a specific heatwave or storm was because of climate change. It's like having a control group for the entire planet. This breakthrough is number one because it transforms climate change from an abstract future threat into a concrete present-day reality. When a record-breaking heat wave hits, scientists can now say within days that it was virtually impossible without human influence. This provides undeniable evidence that links our actions to the disasters we see on the news. This ability to attribute extreme events directly to climate change is a powerful tool for public awareness, legal accountability, and policy making. It removes all doubt and gives us the clear, actionable information we need to guide mitigation and adaptation efforts on a global scale. It is the science that holds us accountable. You know, it's really a game changer. 10 discoveries that have completely rewritten the rulebook for humanity in this century alone. From the code of life to the echoes of the cosmos, we've unlocked secrets that our ancestors could only dream of. These breakthroughs are not just abstract ideas, They are the tools we are using right now to cure diseases, create intelligence, and understand our place in the universe. It's an incredible time to be alive, where the pace of discovery is faster than ever before. What was once science fiction is now the foundation of our daily lives and our future. The story isn't over. In fact, it's just beginning. Each of these discoveries has opened up 1,000 new questions and 1,000,000 new possibilities. What other secrets are hidden in our genome? What will we find on those thousands of new worlds? What will we build with AI? How will we use the awesome power of gene editing? The responsibility now falls on us to use this incredible knowledge wisely. Want the full source list? Check the description. Every claim links to primary papers and institutional reports. Which discovery surprised you most? Comment below. These are the stories that define our time, and we're going to keep bringing them to you. If you want to stay on the cutting edge of what's possible and understand the world of tomorrow, you're in the right place.